Hello everyone, my name is SIT210 and today I am presenting my project pitch for SIT210 Embedded Systems Development. My project is called Advanced Smart Garden Monitoring and Automation System and it falls under the Smart Home Garden and Farm category. In today's busy urban lifestyles, many people love gardening but often their plants get neglected. Current solutions like timers or simple standalone sensors are limited. They rely on fixed schedules, don't adapt to the changing conditions and often lead to wasted resources. This results in problems like overwatering during spring, underwatering in summer heat, and overall unhealthy plants. The gap here is very clear. Existing systems don't integrate the multiple environmental factors and they don't predict future needs. This is where the embedded IoT system offers huge potential. They can provide low power, real-time sensing, local data processing, and remote access for adaptive automation. In fact, this is highly relevant in contexts like urban garden where droughts and heat waves make intelligent water management very critical. So my solution combines of two key devices. The first is the Arduino Nano 33 IoT and the Raspberry Pi 4 is the second. The Arduino acts as a dedicated sensor, while the Raspberry Pi serves the decision engine and automation controller. So it works like the Arduino handles fast real-time sensor readings and the Pi analyzes the data, makes predictions and controls actuators. The two devices communicate reliably over Wi-Fi using the MQTT protocol with UART backup. The goal is simple: healthy plants with minimal user intervention in a system that is adaptive, fault tolerant and scalable. So let's look at the components in more detail. On the Arduino Nano 33 IoT, we have sensors for soil moisture, temperature and humidity using the SIT210, light sensor using a photoresistor, soil pH and an ultrasonic sensor to measure the water reservoir level. On the Raspberry Pi 4, we connect actuators and extra modules, a relay for controlling a water pump, and a servo motor for adjusting shade for the ventilation, a Pi camera, which is optional for now, for visual plant and monitoring, and buzzers or LEDs for the local alerts. The strength of this design is Arduino's efficient low-level sensing complements the Pi's ability to handle heavy computation, machine learning, and multi-threading. And the slide 6 shows how the interconnections and protocols work. So, sensors to Arduino are connected. Sensors are connected to Arduino using the GPIO, I2C or SPI. Arduino to Raspberry is Arduino to Raspberry Pi is via MQTT over Wi-Fi as the main protocol, the UART serial as a backup. Pi to actuators is connected through its GPIO pins, and finally the Pi to web dashboard using Flask for HTTP and WebSocket for live updates. This ensures seamless data flow, precise control and reliable communication. The system flows is continuous feedback. First, Arduino tells all sensor reads all sensor values in less than 100 milliseconds. Second, transmits the data to the Raspberry Pi using MQTT. Third, Pi analyzes and fuses the data, comparing it to thresholds. For example, soil moisture is below 30%, temperature is above 30 degrees. It decides whether watering is needed. Next, the Pi actuates devices like turning on the pump or adjusting the shade. All actions are logged on the SD card and displayed on the web interface. Finally, if failures occur, such as like communication loss or the system retries or falls back to the backup mechanism. This loop ensures the garden remains monitored and cared for dynamically. For the advanced features, I have added robustness, which includes a watchdog timer and a backup communication link, makes the system resilient to failures. The Raspberry Pi can use lightweight machine learning libraries like Skykit to predict watering needs. For example, if soil moisture trends show rapid drying and the weather forecast predicts heat, the system can act early. Real and multi-threading. With multi-threading, the Pi can perform analysis, update the user interface, and control actuators at the same time. This ensures responsiveness. The camera module also enables advanced monitoring such as detecting wilting. Together, these features make the product very robust, intelligent, and future ready. With the system, the expected outcomes are very clear. Healthier plants that thrive with minimal user intervention, optimized use of air and water energy resources, a user-friendly interface with real-time alerts and dashboards, and scalability. So the same problem can be applied not just to a balcony garden but also to a large community farm. Thank you for watching. In this